Okay, I'm gonna create a curve folding with a new plugin from a person I know called Crane. Gonna start with creating an arc, then create some kind of a curvy staircase like steps series, and then try to make some simulated folding curve folding. Alright, so let's start by making a series or range, using a range to create multiple arcs. Alright, like this, and use this as a radius by setting a minimum and maximum. Then I want to shift the odd number and even number of the curves to left and right to have some kind of a interesting shift in between the curves, so that when you fold the curves, it will the final result of the folding will be a bit more interesting than rather than having these arcs arrayed in constant steps, constant distance to each other. So I am going to first get the distance between two curves like this and get the half distance and have some parameters to control the shifting distance. Then use the dispatch to split the arcs series of curves into odd number and the even number curves, and then move it to X direction for the odd number. For the even number, move it to the positive direction, and for the even number, move it to the negative number, so that I could have some interesting curve series like these. And by making even number a mountain folding and the odd number a valley folding, the final result should look like the picture that I show first. Alright, let's do this. Let's convert this to Polygon Polyline. Then, because I have to set the valley and mountain lines, it's an S line, so I have to later on explode these polyline. And I also have to make a mesh out of these polylines, so let's use a loft component to create a surface first, and then let's convert it into mesh. Using like this, I can control the shifting of each odd and even number curves. And in order to convert this into a mesh, I guess there are a lot of ways you can do this, but I want to preserve this square that I see from the surface. So let's see. I am guessing the simplest way to achieve that is to use a simple mesh, but the simple mesh component has some problem with the mesh vertex and the mesh normals. It breaks up all the mesh normals, and also all the points, all the vertices are unwelded, so it's a bit inconvenient to use. But I'm trying to find out if there's any way to simply convert from VREF to mesh, but I guess there aren't, so let's just use this simple mesh component. Alright, and I am going to use a mesh weld vertices component, and I think this is the This is from the plugin called Mesh Edit. I think you have to download that as well in order to use this. Alright, and let's remove the end and the first curve, which is the naked edges. I don't need to set it as a mountain or valley edges. Alright, and let's convert those polyline into lines. And now is the time to create a mesh for the plugin called Crane, the specific geometry for the crane, in order to do the origami simulations, folding simulations. Okay, so first I have created a C mesh. I am going to set the fold speed and the rigidity, and then visualize the simulated C mesh with the visual component. As you can see, the mesh is drawn in black. That is because there is no normal for the mesh from the simple mesh, so I am going to recalculate the normal using a C#, which is going to be easy one script coding, but yeah, and it's a bit time consuming to do that. Alright, now the mesh become white, looks good. Now let's try folding this by setting a solver on and rigid mode on, quad flat on as well. Alright, so this is the result that I get when I create a folding curve, the shifted folding curve with the odd and even number curves. Alright, that looks interesting. If I change the speed of the folding becomes different, become a bit slower. Alright, looks interesting still. Okay, that looks good. Okay, I guess now I can try changing some parameters in order to see if the same process would work with different parameters. So let's try that out. Okay, what should I do? Maybe one parameter I could change is, I guess, the number of base arcs. Right, so let's try to do that first. Okay. Okay, so in order to change the number of arcs, I think I can go back. Well, first of all, maybe I can change those shifting parameters to see how the geometry will look like as a result. And yeah, let's try using developable constraint. This crane component, this crane plugin lets you have additional constraint to the geometry that you made in order to create more controlled folding simulations, and which is really great. Okay, let's set this to a bit lower value to see the difference. Yeah, let's see how it looks like. Alright, so it gives you a less twisting when the arc is arrayed a bit more constantly. Okay, but I like the twisting, so let's set it to something like 0.6. Okay, and also let's try to change the number of arcs and press reset. Okay, let's try this. Okay, it is a bit slow. I guess the reason why it's slow is I'm setting the quad flat on, so if I set it off, it becomes more faster, but the result looks a bit jaggy, doesn't look clean. Yeah, maybe I would need more vertices or more edges, but if I do that, the simulation speed will become slower again, so I guess that's the difficulty of the balance is a bit difficult. And maybe those constraints are making things slower. Yeah, this looks a bit better. Alright, let's also try changing the division number, which defines the quality of the edges or the mesh. Yeah, looks still a bit jaggy. Yeah, okay, it looks more faster, but it's more polygonized. Doesn't really look realistic as origami. Doesn't look curvy. Well, though, speed is good. Okay. Let's bring the number of arc back to lower number like 4. Then also raise up some divisions for the arc in order to create a polyline. Okay, that looks much better. And I might want to turn the quad flat on as well to make it more developable thing. Alright, that looks good. Okay, so that's kind of how you can use Crane in order to create a curve folding simulation. And you can also bake the final output as a geometry to use it for maybe for your fabrication purpose or something. Alright, that's it. Thank you.